Good evening, everyone. Hopefully you're all doing well. Yeah. Okay, so today we're going to do some more here, but the first thing I need to do is actually come up with a good idea. I want to try to do something that that's interesting. Let me bring up the website I've got up here. There it is. And oh, that's not very interesting. Let's see. Well, this is GitHub. I think I mentioned this before. GitHub is a great place to go and look stuff up. I'm actually not... No, I'm not signed in here. Okay, that's good. Terminal-based editor. Assembly language tutorials. Oh, that's an interesting one. Guessing number game. Could we do that? Well, sure. Oof, wow, assembly language. There you go. Crossword puzzle. Okay, let me see. In this project, I have generated a random number. After that, I'm checking the user input with the random number. If it's less than the random number, then I'm printing less than message or greater than. Okay, that's good. All right, so let's see if we can at least start with this. Okay, so let's try to get a random number. So how do we get a random number? This one is okay. No, no. Well, yeah, it's. I don't think we can get a random number. Let's look in our Marie stuff here, because load contents from blah. Yeah, that's fine. But I need something that, like a date, like the date time or the time or something like that. I might be able to do something, but I'd have to figure out a way to bring data in without asking the user for it. And there isn't a way to do that without hard coding it in. We could... Okay, let's try this. Simple random number generator algorithm. Now it's saying there's audio issue, but I don't think there is, right? No, it looks like it's working. Okay. All right. Beta, background. Good. Well, I just want a simple one. List. Here we go. List of number generations. So let's look. Let's just. It's poor quality and historical interest only. We don't care. It's the earliest and most influential designs. Okay, well, let's try it. The Lehman generator is x to the k equals a x, or x to the k plus 1. The next random number is a mod m. M is a prime number, or the power of a prime number, so just call it a prime number. Okay. And the multiplier a is an element of high order modulo. And the seed is coprime of m. The seed needs to be prime. It's kind of a big number. I'd have to study this more. All right, well, is there any here that just say easy? I want some easy to extend for arbitrary. That's fine. I don't really care about that. Yeah, okay. All right, well, we can try implementing something like this. So what we're going to do, let me get a piece of paper here, is we're going to take our seed and we're going to multiply it by a number. Oh, and then we have to do the mod. M. And then in order to do mod M, actually, that becomes a division problem, doesn't it? Yep. And I actually don't want to do a division problem here. Okay, so let's not do that then. And all of them are going to rely on that. So instead, let's use a different one that's really not, it's not even kind of random. What we're going to do is we're going to ask the user to enter a letter and then a digit. And what we're going to do is we're going to add those two together, because we're going to get the Unicode for each of those. Actually, we're just going to ask for a letter. We're not going to even bother with the digit. We'll ask for a letter, get the Unicode value for that, and then we're going to modulo by, not modulo, we're going to, yeah, actually modulo, that's fine, we'll do that. So then we're going to subtract the number 11 from that until we get a number between 0 and 10. Oh, actually, why don't we go bigger than that? 17. We'll go 0 to 16. Okay, that gives us a that's one hex code then. Okay, now that we've got an idea, is there any administrative stuff? There won't be any more lectures for the rest of this week, and next week I haven't had a suggestion yet. So what I'll do is I'll continue working on this as a Marie lesson, and then we'll when I complete that, then we'll be done. I don't think we'll do any more lectures after that. So there will be one more assignment, and then the exam, and then the program 2. I think I have the idea for the program 2. I think I'll probably put that out soon. It won't be due until middle of December. So, but if you wanted to work on it early, that would work out. Okay. So let's just put a comment here. Guessing game. All right, so, oh, I put 2 slashes and I only need to put 1. Okay, so the first thing I'm going to do is get random number. I'm going to put that in quotes because it's not random at all. Okay. So, ask for a letter. Then subtract 17 from the Unicode until we get a number less than 17. That is our target. Okay, so let's just work on that first part first. So we have to ask for a letter, but we probably should first ask the user, or tell the user, enter a number. So print enter a number. Okay, so the first thing we're going to do is I'm going to say, put my caps lock on, jump to print, oops, question. And then down here I have a print question, comma. So the reason I'm doing it this way, so let me get over a little ways here. All right, I think that'll be enough. Okay, so the reason I'm doing it this way, I'm making it longer. So at the end of this, I'm gonna come back to the next comment will be return from print. So the last statement here will be jump. And let me double click on that. Copy, paste. Okay. Oh, and then this one will be input. That'll be the thing we do, is we'll do an input. Okay, after that. Oh, yes. All right, well, let's just assemble this and see what happens. Run. It just comes up here and asks for an input, right? Ooh. Why is it doing that? So the first thing it did is it says jump to question, print question. So we come down here to print question, which jumps to the print, return from print, and then go to input. So for any of you who have started doing your projects, and I think there's at least a couple people that have at least started. Well, what this is actually is a great example of, because at the end of each of these here, I need to put, so I'm going to put that halt there so that it will end. Now eventually that halt will change into something else, but right now we're just going to leave it be. And so let's actually go up here, and I'm going to call this main. And I might call it main loop, but right now I'm just going to call it main. So, oh wait, actually I don't need that. Well, sure, I'm going to call it main, but I might end up taking that out later. So I've got, I literally could put a comment on every single line. It doesn't hurt anything. Not a comment, but label. Okay. So, except for we don't want to return right away. We want to print stuff, right? Okay. So the first thing we want to do is, so what do we want to print? So please, okay. Letter B, oops, B. So I'm going to have to get up my ASCII code stuff. So P is hex, that's HTML, oct, hex 50 is P. Okay. Hex 0050. And I always use 4 because that's how many spaces are out in here. Okay. Letter L, that's a little L. So I'm going to get some scratch paper and I'm going to do, so I got the P, so then I need a little L. Well, let's just do enter. Enter letter. Okay, so let's start with that. I'm just going to get them all. So 45 for E. N, little n, is 6E. Little t, 74. Little e, 65. Little r, 72. A space, 20. Little a, 61. A space, 20. Little l, right there, 6C. Little e, 65. Little t, 74. And then 74, little e, 65. And a little r, 72. Okay. So that will be, actually I want to change this to an E, an N, oops. This is an E, and this is an N. So this is hex, not hex 50, because the big E is 45. And so then this one is 6E, letter T, X, 74, oh, 0074. Letter E, not, oh, I'll need a little E there. And the little e was 0065. Letter R, X, 0072. Oops. Space, hex 0020. letter A, and I don't need to do the space again. Letter L. Oops. X 00 6 C. I already have an E, I already have the T, and I already have the R. All right, that's it actually. Oh, I need to put that. See that? Okay. So here, how do I output them? Load, letter E, okay, see if that works. Assemble, run. Ooh, okay. Now, notice here, okay, let's switch that to Unicode. All right, hey, it did that. Okay, good. So then let's now load letter N and output. Assemble that. Wait, what's it saying? Incorrect form on line 13. Load letter N. Oh, doesn't need the, there we go. All right, run. All right, it printed them out, EN, on the same line, which is what we want. All right, so all I'm going to do is I'm going to copy this. I'm going to start pasting it in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, whatever, close enough. That's enough. All right, EN, T, E, R. So the reason I did this the way I did is, oh, that should be a little R. Space, A, oh, little a. This is space. L, whoops. L, E, T. Actually, aha, I can cheat. Oops. T, T, E, R. Assemble the whole thing. Letter T on line 15. See, it's catching me doing mistakes. All right. Enter a letter. Okay, so it looks good here, except for I messed up there, right? Enter a letter. Okay, so G. Oop. So I did the input. Okay, let's store that. Store, where are we going to store it? Let's store it in a place called what should I call it? Target. I'm going to call it Target. All right, so now what I need to do is, this is where it gets kind of interesting. So jump, oh. Okay, so I got this done. Boom. Subtract 17 from the Unicode. Okay. So, all right, so now I need to go down here. I'm going to make a couple more things. So I'm going to make target. And target will be initially 0. And then the other thing I need to put in here is I need to put my prime. Okay. So that's 17, hex code, right? That's 17. Okay, so I'm going to write another function to do something here. Not a function, sorry, a module. So this one is going to be reduce target. That's fine. We're just going to call it, we'll just call it that. So let's now jump to reduce target. And then the very next line will have return from reduce. Gamma. So then the last thing we do here is jump return from reduce. Okay. So let's take our target. Actually, the first thing we want to do is we're going to want to see if it's above a 17. But in order to do that, we have to subtract 17 from it, right? So do I know that target is already in my accumulator always? Not necessarily. So let's load target. Then skip condition. And again, I'm going to go here and I'm going to look. If it's less than 0, we're done. Okay, so this is going to be done. Okay, so I can put 0, 0 there. So, but we're going to use the same style we did before, and we're going to jump. So we're going to use this condition. We're going to put 2 jumps to it, or at least 1, right? So jump to end reduce. Now we don't have an end reduce yet. Okay. But let's put it here. We'll work out the logic later. All right, so we're going to, if it's less than 0, we're going to skip the end. No, we don't want to skip the end. We want to skip the jump, keep going. And then, oh, actually, no. Let's assume here, so let's go like this. subtract prime. And then actually, instead of doing keep going, we can say reduce target. So we can just jump up there. So if it's negative, if it's not negative, okay, wait. If it's negative, we skip this and we go to the end. Oh man, my connection is not doing the greatest today. Just see that the chat had some problems. Well, we'll just keep going, I guess. I need to probably proof some of these things to try to figure out what's going wrong. All right, so instead of actually calling a jump here, let's just, if it's negative, we need to add the prime back on and then store target. And then what I'm going to do is, I don't need this anymore. Oh, but I do need to then jump back out. Still. Jump to return from reduce. There's the return from reduce. And let's load target and then output the target. Please enter a letter. Okay, so I enter a letter. P. Oh, that's not good. What's it doing? It's loading the target. Okay, so it's reloading every single time. I don't want it to reload every single time. I don't want to go to reduce target. I want to go to continue to reduce target. Or continue the reduce. Okay, that all worked out. Here's my P again. It then output that. Okay, so what I want to do is at the end here, because see how it's on the same line here? I want to go to a new line. So go to my ASCIIs again, and let's look for what would be next line character. We could do a new line like this. We could do an A, 000A. Okay. New page, carriage return. Yeah, looks like just a simple A. Okay. Nope, actually I'm going to call this new line. X000A. Oops, it needs a space there. And then here, load new line output. Enter a letter, P again. Okay, let's try it again. So what I want to do, I've got this P here. I'm going to change this to decimal. I know it. Man. Return from reduce. It loads the target. It outputs the target. All right, well, we got something to print anyways. And if we look here, our target is currently, it's highlighted right there. So it's E. But the problem is if we go here to our table, if we look at E, that's a shift out. And a P reduced to some other invisible character. So it's really hard for us to print that. So I could change it to hex like this, but that messes everything else up. So that gives me this. It's an E. That's good. Let's try that P again. So what was P? P was C. So we go to ASCII characters. Our C is a new page. Okay, that doesn't, it's not actually that helpful. Okay. All right. Let's turn off that output here. Okay. Oh, actually, what I can do, I can turn it into a number. Because, and this is kind of a trick, I'm going to add 30 to this in the hex code. So add, add 0. Letter 0. Okay, so now I need to drop it. I'm going to just go ahead and stick that on the end here. Hex 0030. Oops. So now I'm going to add 0 to that before I print it. P. Oh, I took the output out. The P in there. So 3C is what's saved. Three C is the less than symbol. Let's instead do letter A. Letter A, and then come down here. We don't have letter A yet. Letter A. And what's letter A? 41. Value is a P. Why is it not outputting that? Oh, I put the output after the halt. That would help, huh? So even your instructor makes mistakes. In fact, I make probably just as many as you guys do. The difference is, well, maybe not. I don't know if the difference is, there is that much of a difference, but one of the differences is I don't worry about it. When I make a mistake, it's no big deal. I just keep flying. The other thing is when I notice that there is a mistake, because I've got more experience, and that's really the only reason why, is that I'm going to be able to find that quicker. That's all it is. I just know what to look for. So let's put my P there. Okay, came back as an M. All right, so let's actually change this to. Let me just comment that out. Let me just comment that out for now. Run it, put the P in there again. Okay, so it's outputting something we can't see, so that's fine. Okay, let's try adding 0 again. Let me go back to that. Put a P. Gives me an M. Oh, yeah, because I need to change this. Okay. Wasn't the label that was the problem, it was the actual value of the label. So that's the less than symbol. So less than is here. So this would be 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So P is 12. Oh, 2, 4, 6, 8, 10, 12. So D should be 0. Let's try that. D. Yay! I'm successful. Okay. So it's going to give us a single character hex value. And that's what we want. Are these there? They're not together. Yeah, it's just the way it is. Okay. I don't need it to print that out. And I don't necessarily need to do that either. Okay. So now I've got this number to guess. Okay. So now I want to... So this, I don't need any of this stuff there. That was there for me to make sure that I... so I'm going to jump to print guess. And I can just stick that down here with this other one. Comma. And this is going to look a lot like this one. Load letter G, output. It's going to be a lot, but that's okay. G U E S S space A space N U M B E R B. Nope, that's an M first. M B E R. And here's the cool part. Watch this. It's going to tell me that line 20 is not going to work, so that label doesn't exist. Okay. Okay. Put it here. Right. So I'm going to introduce something that's. I'm going to put all the capital letters together, and I want to alphabetize them. So what is G? All right. Capital G is 47. All right, now we need a U. Okay. Little u. Little u is 75. We don't have a little s. R S 70. There we go. I'll alphabetize them when I'm actually let's alphabetize them now. Here's the cool part. I can actually just look here and I can alphabetize them. This was 74, right? There we go. 74, 75. Space actually should come first. Then 45, 47, 6E. 6E should come after 65. 61 goes here. Six C is here. The new line goes after space. Why am I organizing them? Well, that's a great question. Why am I organizing these? Doesn't make any sense because I could just put them wherever, and it doesn't matter. The reason I'm organizing them, and I'm alphabetizing them, or I'm putting them in their ASCII order of ASCII code. The reason I'm doing that is because if I'm ever curious if one is there, I can look, and it's easy to find. So we've had there's stuff like this. It actually has to do with. This is something that actually came up in our project. It wasn't in this case. We're using labels here with that, but it's similar in Java, which is the language we're using. There's modules that you can create outside of what you're doing. Well, no, it's variable. Sorry, one of the things we do because I'm doing testing, and so we use something called XPaths. It's you could look that up. All lowercase XPath. What they are is it's a way in the product we're using, which is Selenium, to use HTML code and find it. But so we save these XPaths, and sometimes they're actually quite long. I mean, we're talking like 100 characters. Sometimes they get very, very long. And so what we're doing is we're saving them in constants, in a constant. And so we want to make sure that those constants are alphabetized so that if I'm looking for one, it's easier to find. And so, because there could be as many as I've seen, some of our files have like 50 of them or more. That's just I'm just guessing. I don't know. Maybe it's only 30, but whatever. And the IDE helps you find them, but if you're not using the IDE or you're in some other context, it could be really helpful. Okay. All right. So, we need a capital N. Well, I can tell that the capital N goes right here. Letter N. Oops. Letter N. And that's going to be hex. Here's one that's interesting. I'm going to show you how to do this. It's actually kind of cool. Look, this is 65. That's E, little e, right? Big E, 45. So I have a little n, 6e. I know that this is 4e. Let's go look to see if I'm right. Big N, 4e. It's exactly, see? It's exactly 2 away in that first digit. Okay. Look, the assembler, little m. M comes before there, so letter M is hex 006D. And then we need a B here. Letter little b, hex 0062. Hey, I got the whole thing to work. All right, so put in that value. Let's put in that P, that familiar P. Now, it says, guess a number, enter a letter. Okay, wait a second. What happened? I know exactly what happened. So, print the guess, get down to here, and then what does it do? It goes right into the next thing. So, I need to do a jump to return from guess. And then I need to go up here and where did I print that? So then I need to put this right here. Except for it's not going to be a halt that we're going to call. We're going to try, we're going to do an input. So there's that P. All right, input a value. Now, this needs to be a number, and I can't force them to switch to decimal, but let's just do that. So, 6. So we need to figure out if it's higher, lower, or equal. Okay, so, we did that. What time do we have? Okay. We did this. We did that. So sometimes we do this actually. I've seen this in code before. To do. And then, so the things we need to do is, do we have time? We do have time. So we might be able to get this done. And then maybe we can come up with a better way to get a random number. I can come up with a better way. So the to-do stuff is determine if our input. So let's actually store the input somewhere. So let's store that in guess. We'll go down here and I'm going to put a label on this. So I'm going to call this variables. And then here, I'm going to want to tab these all over actually. Can I get them all to just tab over? Can I do it like this? All right. So then this will be characters for printing. Do not change any of these. That means you, Jason. Okay. That's a note to myself, right? Although I'll make it public for you guys to see it as well. So, determine if the guess is the target. Because now, reduce target, are we using that anywheres? Oh, I'm getting emails. It's beeping at me. Oh, yeah. We are jumping to there. Reduce target right here. Okay, so this is main. So what I can do here is, I'm going to call these subroutines. I'm going to categorize this. Subroutines. And then I'm going to name this first one reduce target to 0 to 16 inclusive. This prints guess number. You know, that could be a little n, right? It should be a little n. That shouldn't be a big N. That should be a little n. Little n. And we go down here and we say, okay, little n does exist, so we can go ahead and just delete that bigger one. We wouldn't have to. We could have left it there, but is it determine if it is the target? If so, print you are correct. If not, is target lower than guess? Print lower. Target is lower. If not, then we know print target is higher. Not liar. Or whatever that word was. I'm trying to make up words here in class. And that should be about it. Okay. So, remember, right? That's temporary. I can go and delete that later, but it's nice for me to put that in there because I'm about to end the session here in a few minutes. And when I do, because that gives us some time to work on that stuff later. Right, that's some more logic things. But so I've written a lot of stuff here, didn't I? In just an hour, I put 107 lines in. Now, some of those lines are going to get deleted. But I'm trying to develop some kind of a structure here so that this is my main program here. And this will just be the main part of it. And then I have these subroutines, and each subroutine, actually, has a comment to lead it out. Prints. Oh, yes. Enter letter. I could make this game harder, I suppose. But let's not worry about that. Because this prime here, that's 17. I wouldn't have to use 17. I could use a different one, couldn't I? As long as it's in the space. So when somebody enters in this letter, well, what I could do is I could just ask for a decimal number. And then I could do some hidden math on it. So let's enter a letter. So instead, let's have them enter a decimal number. So our output is always going to be in Unicode, but our input is going to be in decimal. Enter a... I'm going to change this. Enter a number. A number. So let me tell you what I'm doing. Oops. A letter. Greater greater than 100. So space 100. Greater. Oh. Space. Oh, I don't have my caps lock on anymore. Space. Let's just do 100. So then we're going to load letter 1, letter 0, and then I can use that same trick that I did before, where I just do a double output. So then if I hit a symbol here, I'm going to notice here that labels cannot contain white space. It does not. Okay, that's an error message that I haven't seen before. And that one, saying target has a space in it. Okay, so the problem is probably above this spot. What did I change? I added these. Oh, here. No? Oh boy, this is a good one. Okay. It's something I can't find instantly. This is good. Well, that was working, and I didn't change anything there. Okay, good. I did do this. And that. Da, 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 da. Alright. Can I do a double here? Is that going to help me? Labels cannot. This is 115. But that's not the problem. Sees that. Oh. What did I don't want that. No, I don't want that there. I like that. Ah, dang it. I want this back here. What was I doing before? I spaced those over, but I didn't want to. That's a lot of work. That's why. Because the label had a space. It literally did have a space. Now, is there a way, you might ask the question, is there a way to kind of do all these, right? To do all of the characters? And the answer is yes. There is, you could create an array that does it, and then the position in the array is what you have to look for. The problem is it makes it, you just have to do a jump. You know, you have to move forward. You have to do an add to your index, and then you index the array and stuff. It's not really that helpful. You could instead put all of the output that you want into an array that only has one label on it, and then you just go to the first one, and then you advance your counter each time as you index. So similar to what we did before when we, printed out all the numbers. Okay, back to assemble. Okay. Unknown label guess. Oh. Okay, so we don't have a guess down there. Oh, let's put one in. Letter 1. Okay. Where does 1 go? So letter 1 is 31. Oops, I won't do that. So 31 should be here. Oh, yeah. And let's change this to 0. I think actually that'll work because I'm not doing I wasn't calling the letter 0 with a Z. Okay. So we always want to input a number. Greater 100. Okay. And so There should be a little g, and this should be a space instead of a new line. Oh, actually, let's not even do all that. Let's just do a greater than symbol here. Where is that? There we go. So we look and we say the greater than symbol is, do we see it? Right there, 3e. Enter a number greater than 100. Okay, so 500. Enter a value, 5. Enter, guess a number. So now my input can always be. So my labels are a little bit, enter a number greater than 100. And I want that to be lowercase. And I've got two M's there, don't I? I should probably get rid of one of them. Oh, down here. Ah, there's just two outputs on that. Enter a number greater than. All right, so then 888. And the value is 4. Now, do I know what's stored in my... So my prime is still 17, like it was before. I could make that bigger now, right? Can't I? So let's try making it 101. So what's 101 in hex? Oh, wait, I don't need to. Dec 101. Is that prime? Is dec, or is 101 prime? The answer to that is yes. So now, $7.99, and then just 4, doesn't matter. Okay, so I want to know where that's saved. Oh, right there, it tells me, right? But that's not correct, because comments don't count. Okay, try this again. $7.99. All right, so what I'm going to do here is, come on, it's right there, or no, 72. Wherever the 72 is. 72 is still too high. Oh no, because it typed all this stuff out. So I need to figure this out just by kind of deduction here. Okay, so my target, that's been messed with. My prime, oh, my prime is Dec 101. My guess is 0, and the guess has not been changed. All right, so let's look for a 0 in here. I can't move that. I'm not seeing a 0 there, am I? I'm seeing all these 600s. Oops, what was that? I'm learning as I go. ... Search, hide menu, more options. Huh, interesting. Okay, that's fine. Can I... Well, this is easy enough to do, right? Let me get out calculator. 101 minus 16 equals... No. Help if I typed it in right. No, I don't want to do that. I want to... Let me backspace that. Divided by... clear. 101 divided by 16. So 6. And then, so then I subtract the 6. And then times that by 16 again. So 65. 6 times 16 equals plus 5 equals... So 65. Oh, and I can actually verify that here. So 65 is... 65 hex is right there, and 101 is the decimal value. Huh, I could have just looked at this table to begin with. That would have been nice. So if I'm looking for this, I need to find 0065. And that will give me my prime number. That'll tell me where that prime is stored. Oh, these are those outputs, aren't they? Yep. Output is a 6 followed by 3 zeros. Okay. So my variable has to be on this line here. Okay, well, what's the 800? The 800 is the skip condition. Oh, yeah, I want all those. My variables are after all these outputs. That's why I was looking in the wrong spot. Right there. Right there. And there's my target. So my target is 5C, and 5C is less than this, which is our prime. All right. Well, I'm going to save this out. I'll put this out there, and we're going to call this our guessing game, and we'll finish this after our Thanksgiving break. That'll give us something to work on. I need to rethink what I was going to have you guys do. I was going to have you guys do something that was fairly simple, but I think this is actually pretty dang cool. So, okay, that's it. Let me go ahead and download what I've got here, and I'm going to call this guessing game. Let's make it into text and download that. Open that file. Oh, that's right. My stupid computer is dumb. And opening it in Notepad++ to see how pretty it is. And man, look at that. Looks nice. Or at least, I guess, doesn't look bad. I'm going to change that to all caps, though. Oops. Yeah, and then in Notepad, it's all kind of goofy. I don't know, Notepad's dumb. I don't like Notepad. The regular Notepad. I'm going to rename this. All right, so I'll rename this, and then I'll get this out there. There we go. All right, and I'll post that up so that you guys can can take that and look at it if you want. And that's a wrap. Have a good Thanksgiving. And we'll talk to you guys in a week, I guess. A whole week, man. All right. That's it. All right, bye-bye.